All right, with encrypted traffic analytics, or Cisco's ETA, this is really kind of a cool function that we're going to kind of hit from a really high level. Most of us know that we use encryption to keep our data safe, but encryption is also being used to hide things like malware from all of the different security devices that companies try to implement. So what Cisco's ETA tries to do is, rather than try to decrypt all of the data, which would obviously take way too long and way too much horsepower, what we can do is we can look at things like the initial data packet, the sequence of packet lengths, and just the global risk, to be able to look at certain flows and look at specific characteristics of traffic to be able to determine if it is malware. So how does this kind of work under the hood? So the IDP, or the initial data packet, is usually in clear text. It's usually the first packet of a flow, and it's many times going to be analyzed for, DNS info, TLS handshake, such as, the TLS versions and key lengths. We can also use this sequence of packet lengths and packet times to be able to basically provide the number of bytes that a packet's payload is going to be carrying, right? All of these details are going to be creating a pattern, and we'll see kind of an example of what some of these patterns look like over time after seeing enough command and control initiations or exfiltration and key logging. There's these patterns that are very easy to distinguish from our traditional traffic. All right, so what we're trying to do with ETA is be able to not decrypt the traffic, but even as it's encrypted, be able to analyze certain patterns to be able to try to protect our environment from these different types of malware. Now, in addition to Cisco's ETA, we can also implement cognitive analytics. And this is basically a global risk map based on machine learning, right? We talked about this a little bit. And there can be this massive behavioral profile that can essentially be handed out by implementing these two things. So we send things like that initial data packet, the sequence packet lengths and times, or the split, to that cognitive analytics, and all of the data that we get back is going to be very, very robust. So a couple things that we do want to know with regards to being able to look at things like the sequence packet lengths and times is that we do need to enable enhanced Netflow. All right, many times this isn't on by default, right? So once the hardware has been enabled for enhanced Netflow, the additional fields like the IDP and the split are going to be sent to our flow collector. And the ETA MD, or malware detection, is usually used to find things like ransomware. Very, very important in a lot of industries today. Lots of hospitals and companies that contain people's private data are being held hostage, right? And then, of course, we also have the compliance audit, or the CA, and that's generally used for TLS versions and cipher suites. We'll actually see an example of some of this output here, so we can see what encryption authentication algorithm are they using, what is the key length, what is the encryption max. So all of this data, right, we can kind of see when we want to dig down deep into the things that may have raised some flags. So just the slide that I kind of skipped over, if we were in our dashboard and we look at the cognitive threat analytics, and open that up, we can see the stuff that has been exfiltrated. Generally, it's going to have a little bit of a higher flag. It's going to be critical. And then over here on the right, if it's been encrypted, we can actually see that blue box and click on it. And that'll give us an expanded view to see more details about the traffic that ETA found interesting to us.